So for this week, we're going to go over algebra. We're going to remind ourselves of the rules of algebraic notation. Then we're going to think about solving equations by working backwards, or using a flow chart, or using the balancing method. On Wednesday, we're going to review coordinates in all 4 quadrants, and then on Thursday and Friday, it's Mathletics or Genius Maths. You can pause here to read the success criteria for today's lesson, but before you do, I just wanted to remind you that substitute just means swap. So if we substitute in simple values to one-term expressions, it simply means we're going to be given a value for a letter or a symbol, and we're just going to swap that value, that number, for the letter or the symbol. So it will all become clear when we go through some of the skills for today. But you can pause here to go over the success criteria for today's lesson. So our algebra rules, we're going to go over some of the basics of algebra notation. A plus A can be written as 2A, 2 lots of A. We don't need to write the times, we just write 2A. 3P means 3 lots of P. We could write P, add P, add P. AP means A times P. If we've got brackets, we need to do whatever's in those brackets first. So this means 2 lots of P plus A. So we need to add P and A together first, and then we would times it by 2. When we write A over 5, that means A divided by 5. If we were to write 2A plus 3A, we could actually collect the like terms, which would be 5A. A plus A plus A plus A plus A. It can get even more complicated. For instance, 4A plus 2A plus 2P plus 3P. Sorry, the second one was just an A. So that's 5A plus 5P. So in summary, we just write numbers or letters next to each other if we mean multiply. So in the 2A plus 3A example, that means 2 times A plus 3 times A. So if A, our mystery value, was 3, that would mean 2 times 3, add 3 times 3. So 2 times 3 would be 6, add 3 times 3 would be 9. We'd add the 2 together, 6 add 9 gives us 15. And it's exactly the same as 5 times A, which would be 5 times 3, our mystery value. 5 times 3 is 15. So we're going to be thinking about substituting today, which is where you swap a value for the letter or the shape. We're going to go over how to substitute or swap values into an expression. So we'll be given the values for these letters. A represents 2, B represents 5, and C represents 3. And then we've got 3 expressions down below. So we're just going to substitute the A, so that will be 2 times A, which is 2 times 2, that makes 4. For the next one, we're going to take it step by step. So I'm going to put it in brackets. 3 lots of A, 3 lots of 2, add 2 lots of C, which is 3. 3 times 2 is 6. Add 2 times 3 is 6. Add them together, gives us 12. And the next one, BC, means B times C, so 5 times 3. And then we will take away the A. So 5 times 3 is 15. Take away 2 gives me 13. So for this game, you want to go to Google and type in Algebra Smash Hulk. Sounds like a funny game. and it's the first link up the top here. You might need to click to enable Flash. Okay, Algebra Smash. Your mission is to solve the crate arrangement problems before the hunk, should be Hulk, smashes them down. Are you up to the challenge? You will need to work out which terms go into the crates above by adding the 2 algebraic terms below to complete the puzzle. Good luck, and don't make the Hulk angry. Bit of light relief here with our algebra year 6. So we have got x and an x add x makes 2x, so we drag this one up to there, and then x plus 2x gives us 3x, so we'll drag that one there, and then we're adding the 2x and the 3x together, so that will be 5x, and that's your crate problem finished. So you now go on to start again, and you just keep working through. So I'm adding those, so it just continues through and you see how many you can manage to solve. I think there is a time limit. Yep, there is 109 seconds left currently, so enjoy. A bit of a random one, but just thought it would be a bit of fun. Today we're going to look at solving one-step equations. The difference between an equation and an expression is that an equation has an equals sign. So here we've got 4a, or 4 times a equals 32. So we've taken a, our mystery number, and we've put it into a function machine, and we've multiplied it by 4. The number that has come out of the function machine is 32. So if you know your times tables, you will know that if we put 8 into the function machine and times it by 4, it will give us 32. But we're going to use the inverse to work backwards. So 32 divided by 4 gives me 8. So A equals 8. So now we're going to look at a slightly more complicated equation, a 2-step equation, and we're going to solve it using a flowchart, which is really similar to the function machine on the previous slide. It's just an easier way of jotting it down, and we don't have to draw all of the boxes. So we've got the equation 2x plus 3 equals 15. So we started with x, and the first step was multiplying it by 2, because it's 2 times x. The next step was adding 3. So we took our mystery number, we multiplied it by 2, we then added 3, and we got the answer 15. So we're going to use the inverse to help us work backwards through the flowchart to solve the equation. So we start with 15, and then we apply the inverse of add 3. So the inverse of add 3 is subtract 3. And then the inverse of multiply by 2 would be divide by 2. I like to write the steps out before I start calculating. So 15 take away 3 gives me 12. 12 divided by 2 gives me 6. And I must check by applying forwards through the equation. So 6 times 2 gives me 12, and then add the 3 gives me 15. So I've checked and it's correct. X is 6. So there's another very similar problem here. We've got the equation 3a minus 7 equals 17. So we started with a, we multiplied by 3, and then we took away 7, giving us the answer of 17. We're going to use the inverse. 17 plus 7, and then we're going to be dividing by 3. So 17 plus 7 is 24. Divide by 3, gives me 8. So I can check that by doing 8 times 3 gives me 24, add 7 gives me, subtract 7, sorry, gives me 17. So the method I've shown you already with the flowchart is a really good method for working backwards, for thinking of a number questions, but we're going to look at a different method today, which is called the balancing method, and it's the one that you will use when you go to secondary school. We have, as a class, looked at this in around about January time. So we've got the equation 2x plus 3 equals 15, and I'm going to represent this first with a bar model to show you how we solve using the balancing method. So I've drawn my bars. I've got, and I'm just going to label them, x and another x because there's 2 of them, and a 3 is the same as 15. 2x plus 3 is the same as 15. What I need to now do is get rid of the same amount from each bar to make them balanced. So I've now taken off 3, and I want to take 3 off the 15 as well. So I've crossed out in pink what I'm taking away. So I'm just left now with 2x because I've got rid of the 3, and it's now the same as 12 because 15 take away 3 is 12. And I want to get the value of just 1x, but there I've got 2 x's. So I actually need to halve this. I need to get rid of that x, I need to divide it by 2, and I need to split the bar in half. So I'm left with 1x on its own, and hopefully you've spotted what the x is equivalent to. It's 6. So in the next part of the video, I'm going to show you how we can use this bar modelling method to help us with the balancing method that you will be taught in secondary school. So it's okay if you prefer the flowchart method, because that's absolutely fine for using in year 6. You will be doing brilliantly when you go to secondary school. But if you think you can give yourself a bit of a challenge, we looked at this in January, so you can carry on watching the video and give it a go with the balancing method, because as I say, that will really help you out when you start at secondary school. But no worries if you want to continue using the flowchart method. It works just as well for the equations that we're solving today. So here's the bar model that I just completed, where we solved the equation by balancing the top and bottom parts of the bar, by removing the same amount each time, or by doing the same thing at every stage of the process. So we took away 3, then we divided by 2. So for the balancing method, instead of having top and bottom, we have left and right. So it looks a lot more like the actual equation. 2x plus 3 is the left-hand side, and 15 is on the right-hand side. It's exactly the same steps. We simply take 3 away from the left and 3 away from the right, leaving us with 2x equals 12. Then we need to divide that by 2 to get x, just 1x on its own. And we're left with x equals 6. So hopefully if you pause the video here and have a think about the way that the two methods are very, very similar, and how the bar model simply represents what we're doing with the balancing method. So instead of having the top and bottom bar and balancing those, we've actually got the left and the right. So the left side, 2x plus 3, is the same as the top bar on the first part of the bar modelling side, and the right hand side, the 15, is the bottom bar. Moving on to the next section, the 2x is the top bar and the 12 is the bottom bar. And then finally we've just halved it, so the left hand side, the x, is the top bar, and the right hand side, the 6, is the bottom bar. Finally, I just wanted to show you the flowchart example we did earlier and how we would solve that example using balancing. So it's 3a minus 7 equals 17. So to balance, we'll start by adding the 7. to both sides. That gives us 3a equals 24. Then we're going to divide by 3 to get 1a on its own. That's a equals 24 divided by 3, which is 8. So it's the same method really. The steps to follow are generally you want to get rid of the number, the extra number part, so the -7 part first, and then do the reducing it down to one letter afterwards. So I've got 3a minus 7, so I know I've got to add the 7 first because I'm undoing it in the reverse order. Because with BODMAS, remember, you divide and multiply first and then you add and subtract. So to solve an equation, we're undoing, we're using the inverse, so we actually solve it in the reverse order. So, as I said, in the tasks today, you absolutely can use the flowchart method. That will work perfectly. Or you could give it a go using the balancing method, using bar models. It's really up to you, whatever works best. So for the tasks today, Year 6, mild, you will have your own task. Spicy, you will have your own task to start with. Hot, you will actually start with hot task 1. But if you're in spicy and you've finished your spicy task, you can actually do hot task 1. So your first task is to pause the video and to find and explain the errors. So Mariam has described the position of these coordinates but has made some errors. Can you correct them? So for instance, Mariam has put point A, the coordinate as -8, -8, -4. So I know that I move along, forwards or backwards, along first, the x-axis, and then I go up or down. So the first number, -8, should tell me how far along I've gone. So I start from the origin from 0, 0, and she's saying that I've gone along -8. But actually the point is at +8. So that coordinate should be 8, not -8. And then just to double check, have I then for the y coordinate, have I gone to -4? Yes, I have. So that one, A, should be bracket 8, comma, -4, close bracket. So you should be able to hopefully spot the problems with B, C, D, E or F if there are any mistakes. Don't forget, you go along first, that's the first number, and then up or down second.
So let's start off with A. A is in, let's find out why. If I go along the x-axis, I can see that the x coordinate is 8. So it's not -8, it's 8. And then I go down the stairs for this one, along the corridor, then down the stairs, I can see that it's at position -4. So 8 minus 4, she'd got the x coordinate wrong. Let's look at B. Along the corridor to 10, so the x coordinate is correct. and up the stairs to 4. So this one is correct. C. I go along the x-axis to 5. So that's not correct. I can see that the x coordinate is 5. And I go down the stairs, down the y-axis to -7. So you can see here that what the person did was they went down the y-axis first and then the x-axis. So they got these coordinates the wrong way round. For D, I'll go along the x-axis. I can see that it's halfway between -6 and -8. Well, that's actually -7. So this person, what Marianne has done is read the scale wrong here. So if you have gaps like this, you may find it helpful in those gaps with the correct numbers. And then I can see that going down the y-axis, it's halfway between -2 and -4, which is actually -3. So you need to read the scale really carefully. E, well, there's only one coordinate, so this must be incorrect. We always have to have both an x and a y coordinate. So for E, I can see that on the x-axis, I go along, it's at -2, so that is the x coordinate. And then when I go on the y-axis, I can see that it doesn't go up or down the y-axis, it stays at 0. So Marianne forgot to put in her 0 for her y coordinate. F, I'm going along to -10, so that's correct, and up to 9, so this one is correct. So hopefully you saw those errors and realised what the error was. In each case, was just one small thing done incorrectly, but the most important thing to remember is that you put your x coordinate before your y coordinate.
So for today's tasks, I would like you to work through all the tasks from the beginning. So mild, you would work through mild and stop there, unless you want a challenge. Spicy, if you could work through mild and then go on to spicy. And hot, if you could work through mild, spicy and hot. That's just because I really think we need to review some of these coordinate skills. We haven't covered it very recently, and it's something that tends to get forgotten before going to secondary school. So really work hard today. I know that it might be a slightly longer set of tasks, but hopefully hot you'll be able to get through the mild and the spicy fairly quickly. So can everybody try as much of the task as they can, please?